Mushy! Are you ready to graph now? Now that you know all the basics, let's start graphing. This is number 10 from your textbook, and you're looking at part 2 in the graphic notes, graphing the tangent function. Example number 2, describe the graph of the function in terms of basic trigonometric trig function. Sorry, I was reading too fast. Locate the vertical asymptotes and graph 2 periods of the function. So we're going to do this together slowly. Don't worry. And you can see that this coordinate plane of this fancy graph is given to you without any kind of labels, which is kind of like the test. I'm going to give you a clean coordinate, and you can fill it in with whatever you think you need. Okay, I think my camera is lagging a little bit, so I might look a little funny. Don't make fun of me, okay? Also, I'm talking really fast because I didn't want the videos to be so long, because I feel like if you look at me for 16 minutes, you'll get tired of me. So I'll just stop with all the nonsense and just get to the work. All right, so it goes. We do this the same way as you would if you were graphing a normal graph of sine and cosine. So let's just, same technique first. What must you do? I think you should understand and visualize what to expect. This is a positive tangent graph, so you know it's going to look something like that. Sorry, this is so ugly. Okay, you know it's going to look something like that. Okay, and you know it's going to have some asses. Okay, also, let's rewrite first. Let's rewrite y equals 3 tangent. I'm going to pull out the b. Oh, whoa. Something just happens to me. Maybe it's my metal splint. Okay. 1 over 2, and then I'm going to put an x here. I took out the b, so it's very apparent to me what the b is, okay? All right, let's go up, peanut butter. Amplitude is 3, as we know. Peanut, well, it's pi over b. Remember, it's pi over b, not 2 pi over b, because a tangent period is pi. How long one cycle of a tangent is pi, okay? What's the b? B is a half. So we know our period is going to be half pi over half, which is actually 2 pi. So remember, that means this is going to be completed in 2 pi length. What was the STD? The STD was pi. Do you remember the axis happening from negative pi over 2 to pi over 2? All right, so let's continue. Up peanut butter. And let's go ahead and finish everything else. It has no vertical shift, no phase shift. We're going to start basic, you know? And you can tell that because this here, in this graph that's presented to you, it doesn't exist, right? None of this exists. Okay, none of this exists. Okay, that's the first step. So I'm going to put a little line here. Second step, I'm going to graph it my way. But, tricky dicky, I want you to know tangent graph is so much easier to graph. And I'm not even expecting a ton of like points, right? I mean, you'll find the points, but it's super easy to actually calculate the points. Okay, I'll tell you all that after the second step. Second step is super important. This is when you find your asymptote. Oh, asymptotes. This is when you do your asymptote. Asymptote. Dun 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 dun. Always do your ass. So up peanut butter, this, and then ass. Okay, that's what you're gonna do. Now, check out this technique. This method is so beautiful. Are you ready? Now, I want to know, when does the typical ass happen? Or in a tangent graph, when is it first undefined? You're right. The tangent graph is always undefined at plus or negative pi over 2. When tangent is undefined. You know? That's when tangent is undefined. It's when plus or negative pi over 2. I want you to remember that. And we all know that already. So what you're going to do is you're going to set that guy equal to whatever's in here. Whatever's in there, think about why. Because it's the x value that you're trying to find. That's when the asymptote happens. It's when the x, right? But right now, it's not just an x, it's x over 2. That's why we need to find the actual x that'll give me my first s. Okay, does that make sense? So really, this equation becomes bx minus c equal to plus or negative pi over 2. This is how you set up to find the asymptote for a tangent. Okay, we'll do more cases like that. And then you just solve. And then you just solve for x. So our x is going to equal, we just multiply by 2 on everything, right? Plus or negative pi. Because I just multiply this by 2. And this becomes plus or negative pi. That means my asymptotes happen at x equals pi, and x equals negative pi. Okay? And you know what? We're going to start kind of graphing. Let's start kind of sketching. I'm going to make this a little small. Okay, let's set it up. So I know for shizzle, I have the amplitude as 3, so I know I'm going to need some more lines here. Okay, so this is 3, this is negative 3. I know there's no shifts, but I also know that there's some s, right? There's some s. Where is that s at? It's at pi, but also at negative pi. So I'm going to start with my asymptotes. Wow! Wow! Okay. And you know what? If you don't believe me that there's undefined at pi, so plug it in. Let's plug it in. What's pi over 2? Oh, undefined. That's why it's here, pi. If I put pi over 2 like it's supposed to be, it'd be pi over 4. That doesn't work. Okay? It's kind of wrap your head around that, okay? Now, tangent graph is super easy. Here's what happens. Between pi and negative pi, there's pi over 2 and negative pi over 2. Right? It happens every time this way. Right in the center is your 0. 0. And then at pi over 2, it's going to give you the what would happen at pi over 4. I'm going to explain all this, but it's basically right between this and the first asymptote to the right, it's going to give you the amplitude because it's 1 times the amplitude. To the left of it, it's going to be the opposite of that. So your graph is going to look like this. Always. Always. It's that easy. So you have your first critical point here, second, third. Only 3 critical points, but you still need to provide me the equations for the s. That's what's expected for you for tangent graphs. You need to provide me with 3 critical points between the 2 asymptotes here. Okay, well, you know what? We're not done. Let's try graphing another one. What's the period for this guy? It's every 2 pi that this happens, right? So we're going to travel 2 pi. What's that? That means it's 3 pi, right? That means it's 3 pi because we traveled 2 pi, okay? So pi to 3 pi, that's the first one because our period is 2 pi, okay? Okay, then what? Then what, okay? At 3 pi, at 3 pi, there's going to be an asymptote, right? Oh, actually, let's go. You guys see how from here to here it's 2 pi? From here to here is 2 pi. So every 2 pi there becomes an s. And what happens? At 2 pi, that must be our 0. At 3, and then 3. So you can see how you can label those. And I go down 3. And this graph happens again here. Do you see that? Let's do some to the left. Wait, you're like, wait, we're not even graphing that much. You're right. 2 pi to the left, right? So we're going to, exactly. That's how easy tangent graphs are. You could kind of do this. And that's your 3, and this is your 3. Okay? But you only have to label for me the first cycle, 1 cycle, okay? Okay, but let's finish. If you want to continue with the technique that we're used to, third, let's finish this. Third technique is this, graph and labels. Well, you can do the interval, right? What's the interval? It's going to be your period over 4. But your period is 2 pi over 4. So your period, right? Your period is 2 pi. This graph. So it happens every pi over 2. Every pi over 2, this happens. Every pi over 2. Yeah, it's pretty easy. Every pi over 2. Every pi over 2. Okay? But honestly, this is all just extra. Because I think tangent graph, you don't really need all that. But the 4th step is super important. 4th step is going to be you have to state for me the domain. What's the domain of this graph? Now, domain is super easy. If you got to cheat, you can go ahead and cheat. But I'm telling you, the domain is very easy, okay? Now, always start with this. Domain is equal to, okay? Domain is what? Tell me when the domain doesn't happen. That's good enough. Because more times, domain happens, right? Of course, the range is everything, so we're not going to even worry about that. So all real numbers for the range, or negative infinity to infinity. But domain, when does it not happen? X cannot be. X cannot be what? The first asymptote. When does the first asymptote happen? It happens at pi. When does the next asymptote happen? It happens your period. What's the period of this tangent graph? 2 pi. It happens every 2 pi, Miss Chang, but k times, because k is an integer. Every pi plus 2 pi, plus 2 pi, plus 2 pi, negative 2 pi, pi minus 2 pi, pi minus 2 pi, 2 pi. You know, it's going to happen continuously. That's when it cannot be. That's why the domain is listed as what it cannot be. But you know, before I go, and before you digest this, I want to mention something. You know how we said that it just happens that pi over 2 is just 1 times 3? What did I mean by that? You know how usually tangent is 1 at pi over 4? But what about at pi over 2, right? But this is x over 2. So what's pi over 2 divided by 2? That becomes pi over 4. And that's why this is 1 times 3. And that's the amplitude there. Try again. Let's try this guy here. That's negative pi over 2, right? Negative pi over 2. I'm sorry. Wait, this is right here. Negative pi over 2, right? Negative pi over 2 divided by 2. You're right. Tangent of negative pi over 2 is not negative 1. But if I plug in negative tangent of negative pi over 2 here, this whole thing becomes negative pi over 4. So what's tangent of negative pi over 4? It's negative 1. Times 3 is negative 3. Okay? And that's how you can trust that this function works and this process works. Okay? All right, good luck with graphing number 10. Pretty simple. I'll show you the next one too. But you can try on your own this next example if you want to. All right? Bye!